Now we come to set theory. Okay, we have very important results here to show, and I'm sure you will learn a lot out of it, and they will be really useful to us later on. So we're going to define A and B to be two events. Okay, so again, events can be defined by any letter. We usually use capital letter. Okay, A and B. So the set theory has four important results and definitions here. The first one is that the intersection of the two events implies the event that both A and B occur. Okay, so remember A and B themselves, both of them are events. Okay, and intersection is a third event here, talking about the event that both A and B occur. The union, the second event defined here, we write A union B. So this notation, think of it, we call it, you can read it as A union B, okay? And I should mention here, up here, you can read it as A intersect with B. So for union, A union B, it implies that at least one of them occurs, okay? It could be A, it could be B, and it could be both. The third definition is also a event, okay? The complement of an event is denoted as AC, okay? So we use a superscript C. C stands for complement. Sometimes in other texts, you might see A prime to represent the complement or a bar on top of A. In this case, in this course, let's try to use AC. C stands for complement. So AC is the complement of event A that is representing that the event does not occur. Okay, so this notation, okay, S, remember, is the sample space. Okay, backslash A here, that is talking about not A in S. Okay, and lastly, A is a subset of B, implies that the occurrence of A implies the occurrence of B. Okay, and this is the four important definitions here. And you see that down here, we highlight the Venn diagram, which is actually something really useful for understanding set and the relationship between sets. So let me actually use Venn diagram to go through the four definitions for you, okay? So the first one, okay, intersection. Usually, I will recommend you to have a big box to represent the sample space. Okay, that's the capital S, okay? A, let's just say, A and B are both in the sample space. And if this is A, this is B, then A intersect with B is the shaded area, okay? Meaning that both of them occur, okay? You look at the entire diagram, only the shaded area implies that both A and B occur. For two, now you know the trick, so you can draw along as you watch this video. We still have our sample space, okay, as a box. A and B, okay, A here, B here. So here, A union B implies that at least one of them occur, okay? So like we were describing in words earlier, it could be A and it could be B, okay? So you see that the entire space that is being covered by A and B, A or B in this case, okay, is that is what the union represents. Okay. The third one, again, a sample space, and we have, okay, we don't have B here, we only have A, so let's just say this is A. So A is in this circle, and A complement, meaning that A does not occur, right? But it's still within the sample space that we started with, so it's going to be everything outside of the circle, but still, right, within our box. The fourth one is our sample space, okay? So A is a subset of B. So you can imagine a big circle for B, okay? And a small circle for A, okay? So now you can imagine that if A happens, B happens, okay? Because, well, A is within B, right? However, the other direction doesn't work, because if B happens, it's not necessarily that A happens, because it could be everything outside of here, okay? All right, so that's the 4 important definitions of set theory. And let me introduce you to one more. It's called the mutually exclusive or disjoint. Okay, so 2 events are mutually exclusive or disjoint if they have no common outcomes. Okay, so mathematically, because they do not happen at the same time, okay, so the intersection of these 2 are going to be the empty set. Remember our friend empty set, okay? And then using the Venn diagram, so you could imagine you have the sample space, okay? You can have A and B totally separate, okay? So the intersection of them, as we know, no shaded area at all, it's the empty set. And when they do not happen at the same time, like what we're showing over here, we call it mutually exclusive or disjoint. Okay? And I will leave it as an open-ended question for you then. Do you know, or do you have any examples of exclusive events or mutually exclusive events? Okay. And I will give you one. In our course, as you know, Math 241, we have 2 sections, right? One at 9, the other one at 10:30. So one example here will be that a student cannot be in both sections. Okay, student registered for this course can only be registered for one out of the 2. So if my event is event A is student, this student is in section 1, and event B is that this same student in section 2, then A and B are mutually exclusive or disjoint. There is no intersection between those 2.